Have you ever wondered why some objects float in water while others sink? This intriguing phenomenon is all thanks to a principle known as buoyancy. Imagine you're at a pool party and you toss an inflatable beach ball into the water. It floats, right? Now think about a time when you dropped a coin into a fountain. It sank straight to the bottom. Why did these two objects behave differently? The secret lies in the principle of buoyancy. In simple terms, buoyancy is the force exerted on an object submerged in a fluid, whether that fluid be a liquid like water or a gas like air. This force acts in the opposite direction to gravity, pushing the object upwards. Now, how does this work? Well, when an object is submerged in a fluid, it displaces or moves a certain amount of that fluid. The weight of this displaced fluid is exactly equal to the buoyant force. So, if you've ever wondered why that beach ball floats on the water, it's because the weight of the water it displaces is greater than its own weight. Consequently, the buoyant force pushing it upwards is stronger than the force of gravity pulling it downwards. On the other hand, a coin sinks in water because it's denser than the water it displaces. In this case, the coin's weight is greater than the buoyant force, so gravity wins the tug of war and pulls the coin to the bottom. Sometimes, an object neither floats nor sinks, but stays suspended in the fluid. This happens when the object and the fluid have the same density. The object displaces an amount of fluid equal to its own weight, creating a buoyant force that perfectly balances the force of gravity. The shape of an object also plays a role in buoyancy. Objects with a larger surface area displace more fluid, which creates a larger buoyant force. That's why even enormous steel ships can float. Their shape allows them to displace a large amount of water, creating enough buoyant force to counteract their weight. So, to sum it up, whether an object floats, sinks, or remains suspended in a fluid depends on the relative densities of the object and the fluid, as well as the shape of the object. Remember, the buoyant force equals the weight of the displaced fluid, and it's this force that determines whether an object goes for a swim or a dive. So the next time you're at a pool party or tossing coins into a fountain, you'll know exactly why things are behaving the way they are.